Oh, I've heard.
How much information that science tells us about our solar system can you verify 100% for yourself?
Stay cool. This is a Thor News presentation. Thor News presents.
Close Encounter of the Stellar Kind, February 19th, by Plait. 70,000 years ago, asterisk, a pair of stars gave our solar system a close shave. But if you'd been around for it, you wouldn't have even noticed. So saith the Phil. I guess he means that like you'd be a Neanderthal, and much like horses, they don't look at the sky too much, Neanderthals or horses. So the stars are part of a binary system found by astronomer Ralph Dieter Schultz. Little Dieter, in a sky survey taken by NASA's WISE observatory. They're currently about 20 light years away and moving away from us at a speed of about 80 kilometers per second. The real interesting thing is that astronomers carefully measured the star's sideways motion across the sky. That's what we call proper motion. When you stick your hands down the front of your pants in public, that's what we call improper motion. And we found it to be very small. I literally didn't know that was. I didn't know that was the next sentence. Okay, that's funny. I apologize if it was only funny to me. That means the stars are heading almost directly away from us. So sometime in the past, they must have been much closer. 80 kps is pretty fast. Wait, Phil, here's my problem. A lot of scientists tend to look at the stars and think of them in numbers. Where I look at the stars, and I think of them as stars. So there are trillions of stars in the sky, like people. People are different. Stars are different. I'm a little confused, so I'm a little disappointed. You start jibber jabbering about math and numbers without even describing this magical binary pair, because I would think this dynamic duo is far more interesting than how fast they're traveling, or how old they are, or how close they came. You know? Alright, 80 kps is pretty fast. 2.5 billion kilometers per year, or roughly a light year every 4,000 years. Asterisk. For the record, I want to say that I think our knowledge of stellar math is bullshit. It can never be tested or verified. Okay, but I'm not a scientist or a mathematician. I'm just a screenwriter, a video maker, a poet, and a YouTuber. Plus an astronomer. Yeah, you heard me. When you do the math carefully, it turns out that these stars passed by us just 70,000 years ago. You know what? It would make it sound way more legit if you would like stop rounding out the numbers completely. Like when you do the math carefully, it turns out these stars passed us just 72,321 years ago. That sounds way more like, okay, maybe I'll buy that. You guys are always like 70,000 years, 10,000 years. You know, like if you're doing math, I don't think you can just round up 32,000, you know? I'm just saying, trying to help your cause here, buddy. Well, you see, the exact distance at which they blew us is harder to tell due to uncertainties. And I think we can all agree if you're going to get blown, it's a pretty close distance. The best estimate is that they were about zero point 0.8 light years away, far closer than the current nearest star Proxima Centauri, which is 4.2 light years away. On a galactic scale, that's really dang close. Hey, are you quoting Thor News? Okay. Weirdly, though, if you had been standing on Earth, you wouldn't have seen them. Not really that weird, Phil. You should tell that to the amateur astronomers who think, no matter what, they can see everything, like their eyes and telescopes were the WISE telescope times a trillion. The bigger of the two is classified as an M9, barely a star at all. If it were much smaller, it wouldn't have enough mass to fuse hydrogen into helium in its core. The defining characteristic of a star, more or less. What if a star was still a star and gave off light without fusing hydrogen into helium at its core? Would it still be a star? The other is an even dinkier brown dwarf. Not really big enough to be a star, but still far more massive than a planet. Alright, here's my deal, man. Okay, you think you know exactly how stars work? You think you know exactly how old stars are? You think you know how fast they were going? You think you guys know how close they came? And so that's all fine and dandy. But watch, I'm gonna punch into the Google. Alright, M9 star, astronomy. And this is my data. I mean, at best, like this, M9. At best, these are tiny little pinpricks of light, 1 or 2 pixels big, 1 or 2 pixels in size. So it just blows my mind that you give us all these verbose explanations for all things, but at the end of it, the data always looks like this. Or Let's even go to our own star. You go to NASA's Stereo Science Center. You guys are real good at close-ups, asterisk. But when we go to medium shots and wide shots of our star and our solar system, that's Earth, which has been there for like 3 months now, by the way. That is not the subject of this video. Like, that's Earth, and that's the sun. And it's in the fancy colors of red and whitish. So this is the best. I would imagine the solar system is a colorful place. Like Earth is a blue dot. Instead of here, it's just a white chicken-looking dot with a giant coronal mass ejection. So overall, this photograph ain't that great, at all. And then you go to here, and the data's not, this is what the data looks like. Just a bunch of little dots, man. So you guys can churn out $100 billion worth of science papers, improving our knowledge of nearby stars. And then for the medium range ones, we get this. But I do notice we never get like this over like a 1 year time lapse, or a 1 week time lapse, or 1 month time lapse. Even the big fancy photographs are usually one photograph. Sometimes in the Hubble stuff you get like 30 photographs, but it's just most of the data you give us to back up all your grand conclusions looks like this. And that ultimately why, and then you see this and you're like, oh, it's this color, this color, this color, this color. So like each color is like an element for you guys, and so you just plug them in like building blocks, assuming that all light pale blues are water and all greens are methanes or whatever. That I don't think that's how it works. Man. So you can write a 100-page paper. I think this is Jupiter or Venus. There's no color. Can't tell. Can't see shit. Down here, So you write a War and Peace on dark matter or on binary stars, and then the data you give to back up is this. Am I being far too logical for you to be able to respond? Probably. And that's cute, I guess. What choice do I have?
No, I don't want to be misunderstood. I hope you haters know most importantly.
And a lot depends on strong American leadership.
Oh, I've heard.
How much information that science tells us about our solar system can you verify 100% for yourself?
Stay cool. This is a Thor News presentation. Thor News presents
Close Encounter of the Stellar Kind, February 19th, by Phil Plait. 70,000 years ago, asterisk, a pair of stars gave our solar system a close shave. But if you'd been around for it, you wouldn't have even noticed. So saith the Phil. I guess he means that like you'd be a Neanderthal, and much like horses, they don't look at the sky too much, Neanderthals or horses. So the stars are part of a binary system found by astronomer Ralph Dieter Schultz. Little Dieter, in a sky survey taken by NASA's WISE observatory. They're currently about 20 light years away and moving away from us at a speed